In this video, we're going to go over modeling with quadratic functions, and we're going to go over two different scenarios. The first is using quadratic functions to model area. So a company offers rectangular pool sizes with dimensions as shown. Each pool includes a deck around it. If Carolina wants a 15-foot wide pool with a deck, how many square feet will she need to have available in her yard? So we can see from the picture that the width of the pool is going to be x. The length of the pool is going to be 2 times the width, so 2x. And then we also have this 4-foot deck all the way around. So hopefully we remember that the area of a rectangle is length times width. So we need to write expressions for the length of this pool area and for the width of this pool area. Okay, so for the length, hopefully we see that it's going to be this 2x, but also this part here, which is an additional 4 feet. And this is also an additional 4 feet. So we need to add those three parts together. 4 plus 2x plus 4 means our length is 2x plus 8. For the width of the pool part is x, but there's also that part, that's 4, and this part, that's also 4. So 4 plus x plus 4 is going to be x plus 8. And now, while technically that is an equation, okay, we want to simplify that. So we need to distribute and combine any like terms. So 2x times x is 2x squared. 2x times 8 would be 16x. 8 times x is 8x. And 8 times 8 is 64. And then we combine those two like terms together in the middle. And we can figure out that the area of our function, okay, and actually, let's actually write it so it looks more like a function. So we'll say f of x, which is really just area, is 2x squared plus 24x plus 64. So now that we have our function, now we can figure out what's going to happen if she wants a 15-foot wide pool. Okay, so that's just going to be the width. The width is x. We're going to plug in 15 as our x. Okay, we would do exponent first. 15 squared is 225. Next, we would multiply. This is 450. The next one I'm cheating and using my calculator to get 360 and 64. And when we add those three pieces together, we get 874 square feet is needed. Okay, so for your area questions, okay, you're usually going to write expressions for the length and the width, which you multiply together to get the area of a rectangle. Okay, however, you do usually want to make sure you simplify it, which means you must distribute and combine any of those like terms. Okay, the second thing we're going to talk about is a vertical motion model. Okay, so the vertical motion model is this thing right here, which I know it looks a little crazy. Okay, but it tells you h, which is the height. So it's giving you the height of an object, okay, in feet. T is the number of seconds after it's launched into the air. So when something is thrown in the air, when something jumps off of something, it could even be where, you're just dropping it from a certain height and not necessarily throwing it. Okay, you're going to use this vertical motion model. So h is the height in feet. T represents time in seconds. Those other things in there, okay, that v sub 0, that's just standing for something's initial velocity. Velocity is speed, okay, although speed with a direction, but for our purposes, it's just speed. So the initial velocity, and h sub 0 is its initial height. For that case that I mentioned where you're just dropping something, in that case, I'm going to mention that if you're just dropping something, that's no longer going to have an initial velocity because you're just releasing it from the air, not from the air, in the air, you're releasing it. So in that case, there's not going to be that velocity in the middle. So really it'll be zero. So that middle term would not be there. So if you're just dropping it, their vertical motion model looks like h of t equals negative 16 t squared plus h sub 0, which is that initial height. Okay, so we are going to look at this example down here. Oh, and I did want to mention that that negative 16 is just, part of this formula. It has to do with the effects from gravity, so I wouldn't read anything into it too crazy. You can probably do some research on it if you want, but this is kind of just that formula that we're going to use. So example 2, vertical motion model. We have a diver standing on a platform, jumps off with an initial velocity of 16 feet per second. So it wants us to first write a quadratic function that represents the height of the diver after t seconds of the dive. I'm going to scroll just a tad bit up so I can still see my vertical motion model there. Okay, so for this one, we're going to start with h of t. Okay, equals negative 16 t squared. That's just always going to be there for a vertical motion model. Okay, the initial velocity is 16, so that's getting plugged in for v sub 0. So that's plus 16t. That look more like a plus sign. And he's jumping off a platform that is 30 feet above, so his initial height is 30 feet. So that would be the quadratic function that represents what's happening here when he dives off. You notice in the picture, okay, he dives off the platform. It does form that parabola. Okay, it does have an axis of symmetry somewhere. Okay, there is going to be that point that is that maximum height reached from his dive. Okay, so that's what we care about now. It says how many feet above the platform will the diver be at the highest point of his dive? So we need to figure out what is that highest point, okay? Really, what's the maximum is what it's asking. What's that highest y value? And that vertex is going to give us that value, okay? In order to find the vertex, okay, we need to find the axis of symmetry. So we are going to use our equation and find the axis of symmetry from it. Okay, so normally I know it's x equals negative b over 2a. In this case, because it's t for seconds, okay, I will say t equals negative b over 2a, but it's really the same thing. So we're going to have negative 16 over 2 times negative 16. So that's negative 16 over negative 32, which is 1/2. So that means he's going to reach his maximum height after 1/2 of a second. So not a whole lot of time there. Okay, so now we know what that x coordinate is. Now we need to know what that y coordinate is because that's going to be the maximum value. So we just take that t and we plug it in and evaluate. So we have negative 16 times 1/2 squared plus 16 times the half plus 30. 1/2 squared is 1/4, so negative 16 times a fourth. Just bring everything else down. Now I can do my multiplication. Fourth of negative 16 is negative 4. Half of 16 is 8 plus 30. This would be 38, and 38 and negative 4 is 34. So the maximum height reached is going to be 34 feet. However, we do have to be careful because it's not asking us exactly what's the maximum height. It asks how many feet above the platform will the diver be at the highest point of his dive. So if he's already jumping from a height of 30 feet, okay, he's already jumping from a height of 30 feet and he's reaching a maximum height of 34, that must mean that he's going to end up 4 feet above the platform. Okay, so for vertical motion models, you're going to plug in that initial velocity in that middle term, that starting height and that constant, that c value at the end. Okay, if you're looking for a maximum height, that just means you're finding the y value of the vertex. So go through and find your axis of symmetry, plug it in to help you find what that maximum value is going to be.